Hey everyone, can you hear me? All right, perfect. It sounds like we're live, guys. Welcome to Tea Time, and I'm excited to have you here. We are broadcasting to you live, and we are trying Google Hangouts on air. So bear with us as we work out this new technology, but we're excited. And if you have any comments, you can go ahead and post them. Sign into your YouTube account and comment on that, and you'll be able to post comments. Also, maybe we can just do IRC as well for now as we get things going. But our first speaker right now is, well, I guess either Tim or Adam could go first. We can go ahead and start with, let's go with Tim if you're ready. So I'm waiting on Tim to join the Hangout, so just bear with us a moment. And I'm sending the presenters the link right now. So just bear with us a minute. In the meantime, you can go ahead and post comments on the YouTube page, and let's see if that works. I want to see if we get any updated comments. Oh yeah, nice. Sean Frame, Mark Ransom. All right, you guys figured out how to post comments. That's awesome. Now I'm just trying to get Michael or, oh, we got Tim, we got Adam. Okay, awesome guys. So so Tim, why don't you go ahead? Well, Adam, looks like you're ready. Why don't you go ahead and share what you got? Michael Orr has joined. Yep, we got everybody in here. What's up, guys?
Hey.
How you doing?
Oh yeah.
Wait. So which one of us is starting? Is it Michael going first?
You'll be going first, Adam.
Okay. Cool.
Sorry, my chair.
One second here.
A horror movie, kind of like screeching metal thing.
No, I have something different. I'm just trying to get that to work.
Oh, I just saw you. I'm saying yours should be working.
No, I know. My camera's on, but I need the projector to work. The projector's not working.
Screen 2.
Really?
Okay. Can you guys see my screen and hear me all right? Michael, I can definitely hear you.
Just like a 30-second delay. This is weird. I'm watching you here on like a.
Yep, item. We can hear you, and
Cool.
we can see your screen.
Awesome.
There we go.
So a few weeks ago, I don't remember what exactly happened, but Michael Orr and I were in a conversation, and I was complaining that I had all of these notes that were really hard to get into Jira, and I wrote this little project here that I'm showing here called Giraffes, where it gives you like little folders basically that you can clone. Like you clone Jira issues into text files that you can interact with in like using like a Git inspired kind of way. Yeah. So part of the reason for this is that I was going on a camping trip and I wasn't really sure if my internet connection was going to be solid the whole time. And I thought that if I had these text file clones, I could easily like grep through existing tickets and like post comments to tickets that I couldn't actually post comments to the ticket without actually having access to the internet, basically. And yeah, so I wrote this little toy here, and I want to kind of show off a couple of things. So basically the way it works is after you install it from PyPI, which is just as simple as pip install giraffes, you grab your ticket URL, and clone your issue. And what will happen here is it's going to download all of the attachments on the existing ticket and all of the fields and the description and whatnot, and throw them into a few text files here. Oop, I need to go into the folder first. So you'll see that there's a cute kittens picture, which is actually the picture that you can see in the background attached to the ticket. Actually, I hear you guys talking. 1 second here. Oh. So cool. So yeah. So first I'll show you here that if you look at the comments, it'll show you all of the comments that are currently on there. Oh my, then takes. Well, actually there aren't any comments. This is a bad example. If there were comments, they would appear there. And after I add a comment in a second, I'll be able to show you guys that. But it'll also put all of your fields in here, and you can make edits to any of the text-based ones. In fact, like right now, let's change this field. If you run giraffe status, it'll show you everything that you've changed. It looks a little bit awful since this resolution's really bad. Let's also change the description. Cool. Add a couple, or add a paragraph here. It'll see some changes. Let's commit them. And they'll show up as ready to be uploaded. That looks really terrible, and you guys are totally welcome to file a pull request to fix that. It's probably like a relatively simple fix. Let's also upload an attachment here. Computer science. And let's add a new comment. Cool. So we've actually only committed the description and the title. So let's demonstrate that it only pushes the things that you've actually committed. So once you push, it's changed everything. Well, two things. Yay! New title, new paragraph there. But now, it'll upload the photo there, and also add the comment. And you'll see a bunch of messages about it merging branches together. That's all because this is all backed by a Git repository in the background. So there's a little bit of magic that it tries to hide from you most of the time, but it'll give you a little bit of information every once in a while about like branches being merged together. Basically, the Jira branch is holding all of the information from the last time it gathered the issue data from Jira, and the master branch is what you're working off of all the time. But you should never really have to be aware of those details there. Yeah, so now actually if we were to look at the comments, as I mentioned before, it should show that comment there. Look at that. That's fancy. So there's actually one really cool thing that I wanted to show you guys. I built this thing to have like a plugin API so that I could easily like add in. We could easily change the functionality for CMG specific things if I wanted to, and also like still leave the actual underlying program to be make the underlying program usable like in a general way by people that are just using Jira outside of CMG. So I wrote a little plugin that will transform RST things, or RST documents, if you guys aren't familiar, are restructured text. They're the standard Python documentation format. It'll transform those into nice fancy PDFs, because I already keep all of my notes in RST files for like historical reasons. Now I'll be able to make them pretty. So I've actually already enabled that plugin, I think. Yes. So giraffes commit. This specific plugin is the Pandoc plugin, and what it's going to do is transform this RST file into a PDF file on the fly, like as it's uploading it. I hope. We will see a second here. It takes a minute because it actually has to ask Pandoc to transform the document into a LaTeX document, which then gets transformed into a PDF. But Pandoc is handling all of that. I don't actually have to worry about any of the details after asking Pandoc to do the transformation. So now we have this little fancy PDF uploaded here that has the little title, whatever the title of the RST document was, whatever your Git username is in the corner, just in case you need to figure out who generated one at some point. And yeah, and all of the contents of the RST document here. So that is everything I have to talk about here. If you were to go to the Tea Time document, you could find the link to this if you guys are interested in using it or adding new features or whatnot. There's also fancy docs on RTD that you could go to if you had any questions. Yeah. So I guess you guys actually can't ask questions directly this time, but yeah, you can feel free to hit me up on IRC if you guys run into anything.
Okay, thank you very much, Adam. So I think we should give people a minute maybe to post questions, and I can read them off the YouTube channel.
Yeah, it sounds great.
You want to try that? Okay.
Yeah. I think that the delay is like 30 seconds from memory. It's been a little while since I last had to use this.
Replacing Jira with...
Rob, we also don't have the Q&A module enabled from your end, so people could ask questions via that module in the from the Google Plus viewing as well.
Gotcha. So we'll have to play around with that. Adam, that's very fascinating work. Thank you. And I'm glad more people are volunteering. We actually have 31 viewers, and that's 32 actually. That we broke a record. This is the most we've ever had in Tea Time. So previously we've had one speaker the week before and the week before that, and we switched to this, and we're already getting positive results. We're getting a better audio quality, and everything will be archived automatically, and the videos will be transcribed. And we have our own little CMG account, Tea Time account for Google Hangouts on Air. So thanks to Michael Lamb, Michael Orr, Paul Bissex, and a few others who kind of came up with these ideas and helped us kind of test it. So with that said, I guess someone could refresh the YouTube page and see if there are any questions and maybe read those out. Let me know if you guys see any updates. And then you know what? We can always go back to it. So to keep things moving, I will go ahead and pass control to Tim Willis. Test it.
Yeah, there's not think there are any questions. Yeah.
All right. So I guess I'll go ahead. So I'm Tim Willis. I'm new here. I've been here for 2 weeks now. And what I wanted to talk about was an IRC client that I like to use, IRSSI, and a plugin that I wrote for the client. So I'm going to go ahead and share my screen. All right. Can you all see that?
Yep.
Yep.
All right, it looks like we can see it in the Hangout, but hasn't switched over yet. Is there any delay on the YouTube version? Or
Yeah, there's
manually switch that over.
Rebroadcast it delays between 20 seconds and a minute, so just go ahead and press, and they'll see the stream as they catch it up. The only time that'll really come into play is with questions, but we'll just give it a pause at the end.
Okay, fair enough. I'll go ahead then. Okay, so IRSSI, it's an IRC client that you can use from the terminal, which is cool because using the mouse is kind of annoying. Yeah, so some of the cool stuff that you can do with IRSSI. Mainly what I want to focus on are the plugins. So because it's the terminal, it can be...
Tim, could you please blow up your screen some too? Make it a little bigger?
Yeah, sorry.
Thanks.
Any better?
Yep.
Okay. Cool. So, because it's in the terminal, there's some minor annoyances. If somebody posts a link, it can be a little bit harder to click on, so there's plugins that let you see all the links that have been clicked, and then if you want to open one up, you can just open the URL, whatever the link is. That's not going to show up because it's on the other screen, but you get the idea. But anyway, what I wanted to talk about was a plugin that I wrote for AFK. So I've noticed that the culture here is to use the ZNC bouncer, and so everybody's online pretty much all the time, which means that when you log in and out, you have to remember to update your nick before you go, or if you leave your client connected all the time, you still want to remember to update your nickname. And typing /nick, your name, that can be kind of annoying, so I wanted an easier way to do it, and the plugin, you say AFK and the reason, and it auto-updates your nickname. And then when you're back, you can do that. The other thing that it does is there's a loop running in the background that checks for idle. And currently this is only OS X. It checks to see if the screensaver is running, and there's a timeout. So these are all the variables defined by the plugin, and the timeout is 600, which is 10 minutes. So if the screensaver has been active for the past 10 minutes, the plugin will automatically set your nick to name, delimiter, and the reason that you're away, which helps because I forget to say that I'm away all the time. Especially when I leave at the end of the day, something like that. So it can be really useful that way. And then I don't know how much time I have left, but we can actually go through writing an IRSSI plugin if you guys are interested. Rob, how much time do I have?
You're doing good on time.
Okay, cool. So writing a plugin is pretty straightforward. It's written in Perl, and starting at the bottom of the script, there's just an IRSSI namespace that allows you to bind the command that you want to the function that's going to do the work. So here I'm binding AFK, getting the data that gets passed into the command by IRSSI, splitting out the tokens to find the reason, and then calling the changeNick function. That takes a server object which is passed in by our IRSSI, and it has information about the server, so you can be logged into multiple servers, Freenode, Cox server, whatever the case is. And so get the nickname from there, figure out whether, or actually just remove the reason that I'm currently away, and then reset it so that I have a new reason that I'm away. I can demonstrate that too. Pretty straightforward. Yeah, and so that's the AFK, and then auto AFK is a little bit more involved. That sets the last idle time. Let's see. Actually want to do idle check. So it's just a timer. It runs every 5 seconds. And so we figure out when the last time we checked was, whether we were away. Just keep bumping that unless we're actually away. Check to see if we're active. Yeah. So that's the plugin. Are there any questions about why you would want to use this or the client in general? And I would go to the YouTube channel to see questions.
Yeah, so are there any questions for Tim at this time? We could go ahead and wait, or just let Michael finish it off with what he wants to talk about. Michael, it's your call.
Okay.
We're not seeing any in the YouTube channel over here, and there's none from the room, so I guess we can go ahead and press, and if people have questions, they can post them, and we can circle back to them at the end.
Yeah, that sounds good. Thanks, Tim. That was great.
All right, can you all see my screen? The title of the talk? All right, looks like it's showing the slides, so I'm gonna press forward. The talk is titled "Things You Should Never Ever Do with Python," or let's see, or fun with the Python garbage collector and C-types. And obviously, the next question is, what are C-types? C-types is a module built into Python that allows you to proxy Python to interact directly with native C data types and C method calls, things like that, from Python code. So that's kind of cool and interesting, but what can we do with it? Well, one of the things that C-types gives you, if you can read that, it's a little small, is this method called from_address that allows you to give it a memory address and map that directly to a C data type that's proxied by a Python C-types data type. And if that doesn't make sense, that's totally fine. We'll get to that. So something you can do is import C-types, ctypes.csizt from address, give it a 0, and you're going to get a segfault because accessing memory address 0 obviously is no bueno. So that's kind of interesting and neat, but not all that useful. So let's use that and exploit something else we know about Python, which is that it has this ID method which returns the identity of an object, which is an integer or a long, which is guaranteed to be unique and constant for an object during its lifetime. It's not all that special. It's just something that's unique. It's not unique for the lifetime of the execution of Python script. It's just unique and constant for the lifetime of that object. So IDs can be reused. Something that's unique about CPython, which is just a little implementation detail, is that this is the address of that object in memory. So that's how they guarantee it to be unique and constant. So we can combine the fact that CPython uses memory addresses as the ID and the C-types address from to directly address into the Python object construct. So let's take a look at the C code that underlies CPython objects. This is a little bit of C, which we're not going to dig into a whole lot. But basically what you need to see here is that there's a Py object, which is just a blank object, and there's nothing at the beginning, and then this pi size t ob ref count, which is the ref counter. So the first thing that actually takes up space in the definition of a Python object is the ref counter that's used by the Python garbage collector. So we can combine these two things and say that the address of the object's ref counter is equal to the address of the object is equal to the ID of the object. So now we can combine some really fun things and actually get the ref counter of any Python object by just directly addressing that object and then creating a C data type out of it. So if we do that and we create a little method that does this and try to play with it, we create a list, 1, 2, 3, 4, and then we get the ref count. That ref count is 1. So that's kind of neat. We have a list and we know that there's one thing referencing it. And then if we create another variable that references that same list, and we look at that ref count again, it's now 2. It's been updated, as we would expect it to be. If we delete my list and get the ref count, it's 1, so that all makes sense. And if we delete my list too and get the ref count, it's 0. So nothing too crazy here. If y'all are following along and kind of tinkering with this stuff on your own, note that IPython and BPython do kind of weird things with references, and they try to like hang on to references because they do tab completions and some other stuff. But just your generic Python shell will do exactly what you expect it to. IPython and the rest kind of have some, they try to anticipate things and keep references around longer than they should. So if we allocate another list, and then check ref count again, it's 1. But wait, ref count was pointing to our first object. So why is that? And this is one of those weird things about Python, that it actually has a stack of objects that it waits around to allocate. And when it garbage collected the first one, it actually reallocated a new list into that same exact first location that it would allocate lists from. So the ref count for this another list is actually in the exact same memory address location as the ref count for the very original list that we created. And that doesn't seem that relevant right now, but it will later, I promise. And we can see this by looking at list 1 and getting the hex ID list. So this is just the memory location. We can see the memory location of this thing. Not that, super important or cool to look at. And we can make another list and look at the memory location for that. It's different. And then we can delete the first list, create another list, and then look at the memory location for that third list, and it's the same as the first one. So we see that it's allocating the exact same memory that we just cleared up. So this might cause you to go, dude, what? But hang with me for a second. This will all prove fairly interesting. There's special cases in Python allocation, which are int and string. And in the CPython implementation of an int, the references to -5 to 256 are actually shared. They're all the same number. They just have multiple references pointing to the exact same underlying data, and we can prove this. Interestingly enough, if we create x1 equals 257, x2 equals 257, and we get the ref for x1, there's 1 of them. If we get the ref for x2, there's 1. So there's 1 reference for each of those things. That's what we expect. But we can see this. The ID of x1 is not equal to the ID of x2, so that's all fairly normal. But if we get, say, x3 equals 0 and get the ref counter for that, it's actually 1008. For whatever reason, when Python was standing up the environment, it had 1007 other references to 0 that I didn't create. They were just innate to the environment, which is really kind of weird. And we can also see this with strings. If we say p equals Python and get the ref counter for that, there's 8. But I didn't create any other Pythons. There must have been 7 other references to Python somewhere when the environment was, initializing itself, which is kind of weird. So strings really are immutable because when you create one and you create another reference to the same one, they're all the same string. And we can say p2 equals Python, get ref for that, 9, so it incremented like we'd expect. And ID for p equals ID of p2, that's true. So it's actually the same address in memory. What? This is all just weird. So that's neat, but you say, so what? So let's break some things. We've got a reference to the ref counter, which is used by the Python garbage collector. What if we altered it? So we create a list, x, and we get the reference to the ref counter for that list. And we create another reference to that same list. So XX is pointing to the same list as X. So xref 2. We have 2 references to that list. But we modify the value to be 1. We say, hey, there's only 1 reference to this list. Now the garbage collector thinks we only have 1 reference to the list when we actually have 2. And we delete one of those references. So it's going to decrement the ref counter to be 0. Even though we actually still have a reference to that list, it doesn't know that. So what do you think would happen now if we print X? Obviously, this can't be as interactive as I'd like because of the new technology, but folks in the room or folks that are also on the presentation chat, what do you think will happen if we print X?
How often does a garbage collector run?
Very often.
Then probably null.
You think it's going to get undefined?
Yeah.
Or throw an error or something? You think none? All right, so that's a fairly good guess. It actually is the empty list because we still have a pointer to a list. It's a valid pointer to a valid list within the list heap. The name hasn't been deleted from the namespace. X is still a valid attribute, or name, excuse me. But because we had 0 references of that first allocated list in the stack, it destroyed the contents because it had 0 references according to the ref count, so it destroyed the contents. But it's still a pointer to a list.
I thought even the variable type would have been collected as well.
No.
That doesn't get.
No, because Python keeps stacks of different types of objects that can be allocated on the fly. It's still a valid pointer into the list stack. That list that it's pointing to just happens to not have anything in it because it was garbage collected.
Huh.
So what if we create another list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It says another list. Now we print X. What do you think X is going to contain now? 1, 2, 3, 4, 5, 6, 7, 8. So now X actually points to the list we just allocated because it's still a valid pointer to a list. It just didn't have any data. Now it has data. So this should make you go, what? So this is fun with the Python garbage collector. What about tuples? We've always heard that tuples are immutable, right? Kind of. Are they really immutable? It turns out no. So this is the definition of a Python tuple from CPython. As you can see, it's just that PyObject head, which is the same thing from section 1, and then a list of pointers to objects. So in that first section, it was a nothing, a ref count, and a pointer to the data type, and then now we're adding an array of pointers. So that's all we're looking at here. It's nothing too crazy going on. So we have an array of pointers and then the 3 size t things, the ref count, the object type, and the object size. Based on that and the memmove implementation in C types, we can build a tuple copy function. And memmove basically says, give me a destination memory address and give me a source memory address and tell me how much memory to copy. So if we write this function called tuple copy that has a destination, a source, and a begin offset into the source tuple, then we can start copying data. I'm not going to walk through this, but it's just basically a bunch of pointer calculation. So if we create a tuple, 2 tuples rather, x1 and x2, and we print those out, this is what they look like. This is not anything crazy. And then we run tuple copy to x1 from x2, copy from the second item on. And then we print x1, we get AABB, and print x2, we get BB. So we just copied the elements from the x2 into x1, starting with the third element. This is direct memory manipulation. What? Yeah, this shouldn't make you say what. It works, but this should really make you sad. And the reason why is because we've created new references to multiple objects without updating their ref count. Now, obviously, we can go in and modify the tuple copy method to go in and start tweaking with ref counters. And that works fairly okay with strings because they're all shared copies. But when you're dealing with, for example, integers outside of the range -5 to 256, Python expects those things to be unique. So it doesn't know what to do with the number 1,000 that has ref count 3. It's going to not know how to interact with that thing correctly. So you can change the tuple copy to really maintain ref counters, but don't do it. You will segfault. It's just a matter of when and how bad. What about functions? As it turns out, Python functions contain a reference to the code object, which represents byte-compiled executable Python code. Python also comes with a bytecode disassembler module called dis. So you can combine those things for all kinds of fun. It gives you really fun output like this, that you can look at the actual steps that this method is taking. You can start tearing those apart by component parts, figuring out what the memory, the C data construct is there, start directly addressing into memory, and start doing, for example, changing constants inside of a closure of a Python function on the fly. So yeah, I'm not going to dig way into that today because that's fairly deep, but it's really weird and you should never do it. These are things you should never do in Python. So yeah, you can do really, really crazy things. This is the site that I got all this information from. It's basically a one-for-one steal. I can't take credit for any of it, and there's a short URL to the exact same place right there if you want to do some more reading or look at how to break into functions. But yeah, I didn't come up with any of this. I just stumbled across it and thought, wow, this is hilarious and awful. So thanks, CMG. For those of you who don't know, next week is my last week. I'm moving to a different company, but it's been a pleasure. I've worked with some incredibly brilliant folks here and had a blast learning from you all and working with you all. So thank you, and yeah.
It's weird that this is 30 seconds delayed, but
We love you.
All right, thanks very much for that, Michael. We'll go ahead and go to some of the questions. So I saw some in IRC. Paul asked, why would I want to use this versus, say, XChat or Quasil? This is for Tim Willis.
I've never actually used either of those, so I can't speak to it. But I know that the reason I use IRSSI is because of the plugins. You know, you can modify your IRC experience, you know, however you need it to look. So that's why I use it.
Okay, and the next comment, or well, this is pretty much a comment. That is coming from, let me look through here, Michael Lamb. He's mentioned a tech blog that's coming out where we can post comments and anything technical, so stay tuned for that. And I'm really glad that we're getting speakers for Tea Time. It makes me happy. A lot of new speakers like Tim and Adam. And guys, make sure you continue to contribute and speak. You can talk about anything. You can talk about what you did today, what you learned. You can talk about anything informal. But the main thing is this is a social event, so we'd love to hear from you no matter what you want to talk about. It could be 5 minutes, 10 minutes. And I guess we'll go do some more questions, and we'll go ahead and close out from that point. So maybe some of you can help me find them. Some are on IRC, and some are on the live YouTube channel. Okay, well, I don't really see any more questions, but feel free to hit us up on IRC afterwards. And we really appreciate all your time, and congrats to Michael Orr again. We really enjoyed your stay here. Really bright guy, and we enjoyed everything you've done for us. And with that said, I'll go ahead and let anyone make any closing remarks, and then we'll go ahead and close out.
My closing remarks is everyone have a great weekend.
yeah.
All right, so we'll go ahead and leave on that note. We really appreciate it, guys. And if you want to look at this broadcast again, you just go to the YouTube channel. You could go here every week and just look at the archives because it's recorded seamlessly. And we appreciate everything. So y'all have a good weekend and take care.